Hi class. Now we can talk about some intermediate level of algebraic equations. Remember in the previous video, we talked about how to do like some simple equations that maybe 2x equal to 4. You simply do the reverse operations. Where when you have additions, whenever you see additions, the reverse of it will be subtract. Whenever you see multiplications, the reverse operations of that will be to divide. So in this case, I have 2 times x equal to 4. I see a multiplications in here, so I have to do the reverse of it, which is to divide by 2 or multiply the reciprocal of it. And if I divide by 2, I have to do it on the both sides, just to keep the balance to have equal weight. Now I have x equal to 2. You can backtrack yourself, plug in, evaluate if x equal to 2, plug back to the equation we start with, see if that will get you to 4. 2 times x is a 2, equal to 4. 4 equal to 4. So x is indeed equal to 2. So that's how you can backtrack for yourself. Now we're going to do a little bit more complicated stuff. That is, we will involve more than one operations. Because in the previous lectures, we only focus on how to do reverse operations on one specific operations per equations. So in this case, we might see maybe 2 or 3 operations per equations. So let's see. Question number 1. Let's say I gave you 5x plus 8 equal to 6. Okay, well, you see a multiplications in here. You also see an additions in here. And just a reminder is that whenever we deal with algebraic equations, the final goal is to come down to the solutions of a variable equal to a constant. That's our end goal here. So now how can we get to here from the question itself? Okay. In this case, it is unlike what we learned about pandas, where you have to focus on multiplications, divisions first, then subsequently you get to additions and multiplications. No, in reverse operations, everything has been reversed. So when you have additions, when you have like combinations of additions, subtractions, multiplications, divisions, you should focus on addition, subtraction first. Okay? And then you will work on your multiplications, divisions. So in the question in itself, because there's a plus 8, and now the addition subtractions will take priority of our algebraic equations. So we will minus 8 first as a reverse operations. Then plus 8 minus 8, that gets you 0. It will be 5x equal to 6 minus 8 is negative 2. Now what you've left is a multiplications. 5 times x gets you negative 2. So the reverse of multiply is to divide or to multiply back the reciprocals. So divide can also be perceived as to multiply the reciprocal. Of the coefficients. Okay, so now I will divide by 5 or multiply 1/3 on both sides. X equal to negative 2 over 5. Okay, now I've come down to a variable of x equal to a constant of negative 2 over 5. Now let's take a look at question number 2, where 9 equal to 3x plus 15. If possible, I suggest you pause at this moment and try to solve this question by yourself. Just apply the note on the first questions and I think you'll do fine. Okay, question number 2. Now I have 9 equal to 3x plus 15. Again, we should take care of any addition subtractions first. So in this case, I will take care of the plus 15. So I have to get rid of the plus 15 by having a reverse operations, which is minus 15. If I do it on one side, I have to do it on the other side. Plus 15 minus 15, that gets you 0. What's left is 3x equal to 9 minus 15, which is negative 6. Now what's left at this point is a multiplications of 3 times x gets you negative, so 3 times x gets you negative 6, yes. Divide by 3 on both sides. Again, whatever you manipulate the operations, you have to apply that to both sides. What's left is a 1x, because 3 divided by 3 is a 1. Negative 6 divided by 3 is a negative 2, which means my x equal to negative 2. You may notice in your textbook where the authors prefer you to have the reverse operations in a horizontal way. So meaning, well, let's copy the question down again. We already have spoken about what we should do first, which is to minus 15. So according to your textbook, that's how you will actually do it, but I honestly don't care. It'll be 9 minus 15 equal to 3x plus 15 minus 15. So I wrote the minus 15 on both sides in blue, so you can see that they are of equal weight. Because whatever you've done on the left side, have to apply the same thing on the right side. And at this point, now you can still clearly see plus 15 minus 15 gets you 0. If that's how you want to do it, be my guest. At the end of the day, you still have the same thing of 3x equal to negative 6. X has to become negative 2. Okay, example number 3. Let's say you have 3x plus 10 equal to 1. Again, take care of the addition subtractions first. That will give you 3x equal to negative 9. Divide by 3, x equal to negative 3. At some point, you might want to really check the algebraic equations by yourself by evaluating the equations. We learned about evaluating equations or expressions in the previous weeks, where we just substitute the value of x back to the equation itself. So that will become 3. Let me start with the normal color. 3 times x, which is negative 3. The red ink represents x, plus 10 equal to 1. Well, let's see if that is true or not. 3 times negative 3 will get you negative 9, plus 10 equal to 1. Well, if you want, draw yourself a number line, starts with negative 9, because it's a plus 10. When you add the positive numbers, you move into the directions of the right. So you move 10 units to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can fill in the numbers in between them, but the answer is 1. So 1 equal to 1, that is a check. Question number 4. Let's take a look at this one. Negative 13m minus 1 equal to negative 1. Take care of the constant first. So plus 1 on both sides. That will minus 1 plus 1 get you 0. Minus 1 plus 1 get you 0. So you should have negative 13m equal to 0. Well, don't panic at this point. Just keep doing the math. Divide by the coefficient. Negative 13 divided by negative 13 gets you positive 1. M equal to 0 divided by anything. Regardless of positive or negative numbers, it will always end up with 0, meaning m equal to 0. If you want, check it for yourself. Negative 13 times m, what we find the m is, that's a 0, minus 1 equal to negative 1. Let's see if that's true or not. Negative 13 times 0 is also 0, minus 1 equal to negative 1. You minus a integer, so you should apply KCC, although that's really unnecessary in this case. That will become 0 plus negative 1 equal to negative 1, well, which is the same thing. You still end up negative 1 is equal to negative 1, which is how you know you have the m of 0 is the right answers. Number 5. I have 6 minus x equal to 3. Well, in this case, they are so-called two ways of doing this. I'll show you both ways as well, because what we've been talking about is that we should move away the constant first. So get rid of the constants of negative plus 6, because this is a positive 6. To reverse it, you have to minus 6, which end with 6 minus 6, that gets you 0. I have a negative x equal to negative 3. But that's not what I want. Again, the angle for all algebraic equations is that I want to have a variable equal to a numbers. I'm not looking for the negative variable equal to something else. That's not what I'm looking for. I'm looking for a positive variable, which is x, equal to a numbers, not negative x. So what to do is that you can have both. You have two strategies to approach these questions. One is plus x on both sides, so that negative x plus x, that gets you 0, equal to negative 3 plus x, and then the last step is to move the 3 back to the other side. Negative 3 plus 3 also gets you 0. 0 plus 3 is 3, equal to x. That's one strategy, which is to switch the placement of it and get the variable become positive. Another strategy is that, well, to me, it's more a simpler strategy, but when we come to this point, negative x equal to 3, what I can simply do is that I can represent these equations at this point to become negative 1x equal to 3, negative 3. So now I can clearly see that there's a coefficient of -1. Well, how can I get rid of the -1? In this case, divide by -1. Now -1 divided by -1 get you +1. So that gets you +1x equal to 3, which just means x equal to 3. So you can see that both ways will get you to the same answers. And that's about it. At this point, you just learned a new types of algebraic equations where you have to you might see the combinations of additions, subtractions, and multiplications, divisions. And to recap some of the stuff is that you always try to tackle down the constants first, which is to take care of the plus minus first, and then subsequently move forward to multiplications, divisions. Okay.